So we are going to conduct a paired sample for two means. So here, what we are going to do is this is the set of students for which we have the marks for the 2 semesters. So before we go into the inferences, first let's try to do the t-test on Excel. So you go to the data tab where most of your analysis is going to happen. Go to the data analysis and take t-test paired to sample for means. Press OK. It will ask you for your variable ranges for the two distributions. So the first variable range I can keep as my first semester results. In fact, I can take the entire thing for variable 1. Similarly for variable 2. Hypothesized mean differences will keep at 0. Remember, for null hypothesis, we have to, if the null hypothesis is true, it means that there is virtually no difference between the means of the two distributions. And we'll take the labels because I've included them on the exercise. Alpha is 5% significance level, which is 95% confidence level. And the output range I can keep somewhere on the sheet. So let's say I keep it here. And I press OK. Now, the moment you do that, your t-test results are out. I always convert this to 5 decimals, easier to read. Apart from these numbers like mean and all, they don't require to be. Observations don't require to be. Now, first step is to validate the correlation between the two data sets, which I can validate using the correl function is equal to correl array1 and array2. You will see that the correlation is exactly the same that you are getting here. Right? 0.84139. Degrees of freedom will be 9 because there are 10 observations. So 10 minus 1. Now let's compute the t-stat. So for the t-stat, we will use this formula that you see. First, find out the standard error. The standard error is nothing but the standard deviation divided by the root of number of observations. Now please remember, variance is the grosser measure of risk or volatility. And standard deviation is the root of variance. So since we are taking standard deviation, we have to take the root of number of observations. So standard deviation divided by the root of number of observations is a more scalable measure of the standard error. So let's find out the standard error first. Standard error is, now please remember, first we need to find out the delta, because the delta is what is we are concerned with, right? The delta between the two distributions. And the delta between the two distributions will be simply the one distribution minus the other. And drag it down. So this is the delta between the two distributions. Next, we find out the mean of this distribution and the standard deviation of this distribution. So mean is nothing but the average, right? Standard deviation ke liye we can do T.DIST.2T. This is your standard deviation. Now this standard deviation we can use to get the standard error, which is standard deviation of this delta distribution divided by root of the number of observations. So this is your standard error. Look at your standard error. It should be 2.30555. Now we can use this standard error to get your t statistic for this distribution. So T stat will be equal to the standard error, the mean rather, the mean of the distribution divided by the standard error. Mean divided by standard error, which comes to 7.63376. Can you see this matches identically? So that's how you get your T-stat. Your T-stat is the mean of the delta distribution divided by the unitized standard error. That will be your T statistic. Now, what we have to do is we have to compare the T statistic with the T value for a two-tailed test. Now, the question you will ask is, sir, how do we get this value, this two-tail wala value? Can anybody tell me? So basically, if you want to see how you get this value, just you can do this is equal to T.INV.2T, T inverse test for a two-tail. Probability, we will take 5% significance level and 9 degrees of freedom. Now, can you see what number I have got here? 2.26216, which is the same number that you are seeing here. Right? So basically हम क्या बोल रहे हैं? If we draw a normal distribution on either sides, that means you take this 2.262. So on the left, minus 2.262, on the right, plus 2.262. If your T stat for this distribution is less than minus 2.262 or more than plus 2.262 on either sides, you are going to accept the null hypothesis. Accept or reject? Reject the null hypothesis. You will accept the null hypothesis only if it falls in the between. Okay, na? So since your T stat is minus 7.63, which is lower than minus 2.262, so we will reject the null hypothesis. T stat, which is minus 7.63376, is lower than T critical value, which is minus 2.262, right? So we reject the null hypothesis. Next is to look at your p-value. Okay. Your p-value, you can, it is much lower than 0.05. If your p-value is lower than 0.05, then what does it mean? Again, .05 is 5% significance level, which is your alpha. If your p-value is lower, again, what is the significance? We reject the null hypothesis. So what are we seeing in this case? We are seeing that both p-values and t-statistic is representing the same result, that the null hypothesis is rejected, which means the population means aren't similar, which means that these two tests cannot be said as equivalent in terms of preparation or toughness. That's how you would interpret these results. So that is how you conduct the t-test for a paired to sample for means.